your standard 6, we're talking about exponents and simplifying them. So we got to write down our properties first. First one is the product property, and then a little example for you there. All right, guys, do you remember product property? When you're multiplying, if you have the same base, you just add the exponents. Yes? Okay. And let me show you, I think you guys are all fine with it, but why this works, it's not just a memorization thing. So x cubed, that's x times x times x, right? And x to the 4th is 1, 2, 3, 4. So how many x's are there? 7. So that's why it's x to the 7th, okay? All right. Power of a power. When you have an exponent raised to another exponent, that's when you multiply them. And guys, I know this is review, but I want to go over it. You're usually very good at these properties on their own, but it's when we combine a bunch of them that sometimes things get a little fuzzy for you. So just want to make sure we're super solid with the basics first. Okay, and again, guys, you don't have to write this down, but this is just showing you why we multiply. So if it's x cubed to the 4th, that's actually 4 of these x cubes. And each x cubed is 3 x's, right? So there's 12 of them if you were to write it all out. I do not expect you to write any of these out like that, okay? Just showing you why it works. All right, quotient property here. Quotient means divide. Again, don't write it all out like this. But when you're dividing, I think you guys know you're supposed to subtract. But let's look at why that actually works. So if I have x to the 5th, which is 5 of those x's, y to the 4th over x cubed, y to the 9th. You guys can see that if I cancel out my common factors, I've got 2 x's left up top, so x squared, and 5 y's left in the denominator, so y to the 5th cancel out, okay? That's what you're doing in your brain every time. Okay, 0 power. Do we know that anything to the 0 exponent is 1? Sorry, guys. All right, negative exponents. This is where it starts to get a little trickier. Jot it down and then we'll go through what's actually happening here. Okay, when I have a negative exponent, what does that mean? I need to move it down. Okay, is the y squared going to move? No, it doesn't have a negative exponent. So I'm going to end up with an x cubed and a y squared in the denominator, right? Does the whole fraction become negative because of the negative exponent? No, okay, it just moves things. What's in the numerator? Good. No stuff. Good job. All right, what about this one? If I have a whole fraction raised to a negative exponent. I'm going to show it in 2 steps. You can certainly do this in 1 step. The negative exponent, that means everything's getting flipped, right? So the b squared is actually on top and the a cubed is down below. And then it's still the whole quantity squared. But again, I'm fine with you going straight to the final answer of b to the 4th over a to the 6th. Okay. All right with that? All right, rational exponents. Rational is just another word for fraction. So x to the 3/4, what does that actually mean as far as like roots or radicals and all of that go? What'd you say, Kitty? Okay, so and you can just say the 4th root. So the 4th root, so you gotta have a little 4. That's called the index, in case you're wondering where I'm writing the 4 here. Of x cubed, or you could write it this way. You could say the 4th root of x and the entire thing cubed. Those mean the same thing. If you actually have numbers and you're simplifying, you can pick whichever route is easier. Usually this one's easier if you have a number. So you take the root first to make a smaller number and then cube it, instead of having to take the 4th root of a really big number. All right, so that's the end of the actual properties. Anybody questions on any of those? Am I right that those are all familiar to you? Okay. All right, so let's try. Okay, let me fix all of this real quick. Okay, guys, examples. Let's just jump in with lots of fun on this one. guys want to try, or do you want me to walk you through this one? Try. Okay. My tip: simplify in the parentheses first. Okay. Start there. But yes, you guys can try. Talk to your neighbor, see if you agree.
I wrote it. Because it's Wow. This case is hurting out. I hope they'll find it on. You're multiplying.
Yeah, of course.
Yeah, I mean,
That calculator. Okay.
Allie on it.
Take notes, man.
Ray, Megan's on it.
Oh, I thought you meant two numbers. You were. Only because they're my pencil. It's because no.
This part you started right though. You guys said weird. Oh,
So they use a different number.
this? That's fine. Don't like The only time you do like the reciprocal part is okay, guys. The answer was C to the 11th over D to the 5th. Most of you got there. Start in the parentheses here. So I end up with C squared and a D left, which is going to be 1 over C to the 4th D squared. Right? Are okay with that? Then your other parenthesis, that -2 brings those C's to the top, so we get a C to the 5th in the numerator, and a D in the denominator. So when I cube that, that's C to the 15th over D cubed. Okay. From there, guys, it's just multiplication. Do you see how there are no addition or subtraction signs? Okay, so you can cross out anything in the numerator with anything in the denominator because they are all factors. So I see C to the 15th over C to the 4th. That's going to leave me with C to the 11th. D squared times D cubed is just D to the 5th. Okay? All right, let's try another one. Feels like there should be a denominator in that. Let's see. We'll make it A to the -4th C cubed.
Oh, is that 6a squared?
That is 6a squared. That's not BA squared B. Sorry, that's a 6. Yep, my 6's and my B's are tricky. Wait, what? Oh, yeah.
First 2 and 4 times. I love your time. It's so funny.
We're starting the parentheses. So,
You bring that up.
Yeah.
so, well, what would it be if you brought it up? It's already A squared up there, so,
Oh, okay.
yep. And then you're gonna bring it up and down. So. Lots of stuff moving around.
Yes, you do, because it's all negative. Negative one's outside, so you have to go. Silly. Silly, silly. Minus 62. Oh, that's
We don't want fraction. It's just so much.
4 over 18.
Yeah.
That's 4 over 8 squared. On it, what'd you got? 4 8 cubed b over 81 c cubed. Oh, right.
Oh, no.
What is that?
I don't know.
I thought it would be.
I'm sorry. It's a 6.
Well, it's completely ruined it.
You lost it. Why is where happened to this? You just forgot. We're not. Yeah. Like finding out what that's
Yeah.
Yeah.
I know. There's just a lot going on. Yes. That's what I mean. Like, isn't this super easy? There you go.
Yeah, I know.
Yeah, it's not a negative.
That's what I like. Yes. Not yet, not yet, but I can see it in the future. But not right now. Yes, I know. No, no, no. No, you're right. No, I really almost told you don't call it. And I really thought it was, yes.
You lost something somewhere, but maybe not.
So like don't. That's not official yet.
So that's okay. So I think you got the
I can do
idea.
it myself.
All right, let me baby step you through this one. So remember, simplify in the parentheses first if you can. In that first parenthesis, is there anything to simplify? No. All right, 2 cubed. Anybody say 2 cubed is 6? Okay, good. 2 cubed is not 6, it is 8. And then this would be a to the 9th, b to the 3rd over 27, c to the 6th. Okay with that? All right. The second parenthesis, I'm going to go off to the side here so that I don't have too many steps going on. If I simplify in it first, you guys see how it's 6a to the 6th b over c cubed? Are we okay with the a is what's going on there? And then to the -1, so this is all getting flipped. So c cubed over 6a to the 6th b. All right, let me stop there. Anybody questions getting to that point? Look at your paper. If you're like, mine is different and I don't know why, I'm happy to come look at it. All right, guys, from here then you're just simplifying. When you're multiplying fractions, remember you multiply straight across. And then as far as reducing goes, anything in the numerator with anything in the denominator. So if I look at just the coefficients first, the numbers, 8, 27, and 6. Guys, you want to have a calculator on this. So I would reduce before you multiply. What can I reduce right away? Out of 8, 27, and 6. What? 8 and good. What's the 8 going to become? 4. What will the 6 become? Okay, so I know that I have a 4 in the numerator, and what's 27 times 3? 81. Okay. All right, then I'm going to look at the A's. How many A's are going to be left? Where are they going to be? Yep, so A cubed up top, right? What about B's? B squared up top. What about C's? And where is it? Okay. There is your answer. How we doing? Take your time when it's all of those rules together. You gotta just slow down a little, piece at a time, okay? All right, let's keep going. And we haven't done any of the fraction exponents yet, so let's look at that. All right, guys, jot it down. There's a couple of ways I might ask you to do this. Let's make the directions this time. Yep. Yeah, I don't know why it looks like there's a decimal in there. Get rid of that. That would be a strange number to do to the 1/2. We'll say simplify with a radical. Okay, what does the 1/2 outside the parentheses mean? Square root. So this is really the square root of 16, a to the 5th, b to the 9th. Do we know the square root of 16?
Yes.
4. Okay. Now the variables here. It's a to the 5th. If you think about it, 5 times 1/2, that's going to leave you with a fraction, right? Okay. So what you need to think about is the index here would be a 2. How many times will 2 go into 5?
2 times
2 with how many left over?
1.
1. The leftovers get stuck under the radical. You said 2, so I'm going to write a squared outside, 1a stuck under the radical. Okay, b to the 9th. How many times does 2 go into 9? 4. How many left over? 1. So that is simplified with a radical.
Yeah.
Okay? Makes sense what I'm looking for there? So that's that. I could have asked you to just simplify with rational exponents, and then you'd tell me like 4a to the 5 halves, b to the 9 halves, like you would just leave those fractions, but yeah, we'll do, this is better for this one. Okay. So let's try again. All right, you guys try this one. Yeah, I don't want it to
No, I don't think that. I think we should do it during this period. Fourth period.
I feel like there should be. Okay, but I would probably need to go.
What? What? 9:35.
Now I know who you guys are.
2x y. 2x squared y z squared.
Yes.
That was I was
Like I hope that was like 6 times 6 like that, and then I stopped there. So I'm gonna go for 36.
I know.
Oh, I want you to say radical. So I want you
It's bad to like scroll a little bit.
oh my god.
He gave me a fist bump for the first time.
One.
He has like,
Alright guys, let's go through this one. The cube root is clearly harder than the square root. I'm not going to have you do all of them. And okay. Alright guys, this is what this means. Cube root of all this, right? If you need to, go over to the side and figure out cube root of 16. I don't care which way you do it. If you're an I like perfect cubes kind of person, great. If you're a like, whoops, that's an 8. If you're a this and you circle a bunch of numbers kind of person, cool, as long as you know what you're doing. I find some people do this and they circle a bunch of things and then they're like, is that it? No, you gotta know what to do with your circles. So I don't care which way, just make sure you can do it. So are we okay with there being a 2 on the outside and a 2 on the inside? Okay. X's. How many times does 3 go into 5? How many left over? 2, okay. How many times does 3 go into 10? 3. How many left over?
1.
Okay. Does 3 go into 2?
No.
Okay. That is your answer. It's kind of long. Like, it's just, it doesn't look any nicer than what you started with. All right, we okay with 4? Make sure you read directions in this section or this standard. All right, because we still have a radical here, but my directions have changed, right? Using rational exponents. It's a little different. It's not bad. It's an S. Sorry. 16 S to the 12th T to the 15. Okay.
Like, we're on fire back here.
Good. Like, not just it's hot in here, right? You're actually like, you know your math today. I like it. Are you okay? It's cold in here usually, yes.
Go outside.
I know, I like it. I know. I'm ready for it to be fall. I don't need any more like 90-degree days. Yes. My son has like outgrown all of his shorts and I don't want to buy him more shorts. I'm like, you're sweating. It's fine. Okay guys, so rational exponents, that means write it with a fraction exponent. So if it's the 4th root, what is the fraction? Okay, so a couple of things you have to think about. That means you're doing all of this to the 1/4, okay? With the coefficient, first think about what the 4th root of 16 is. Do we know it? 2, okay? Then realize you are just multiplying exponents. So this is really 12 over 4, and this is t to the 15 over 4, right? Power to a power, you multiply. And then if you can reduce those exponents, you should. So what is 12 over 4?
3.
So this is really 2s cubed. Does 15 over 4 reduce? No, so it's just t to the 15 over 4. That is your answer. If your coefficient, if it was not something that you could take the 4th root of, like let's say it was like the 4th root of 9, you would just write 9 to the 1/4. Okay, if you can't actually take that root, that's what I want you to do. Does that make sense? Okay. I think we have 2 left, guys. Or maybe just an A and a B for this. All right, express using a radical. So write it down. That's a 3 and a 3/4 if you can't read. A to the 2/3, B to the 3/4. You okay? I know. Yeah, I'm going to show you. I just thought I'd let you write it down. I know you guys don't listen while you're writing. Like, I know this. I don't try to talk to you while you're writing. All right, are we done writing?
Yes.
Okay, so we need to pick a radical here. They have different denominators. So how do I pick one radical? Okay, so common denominator? Yes, that's what you mean, yes. All right, the 12 out in front, the coefficient. Just leave it outside of the radical, guys. It's so much easier. So I'm going to have a 12 outside of whatever radical I pick. What is the common denominator? Like if I was going over here and I was trying to add 2/3 and 3/4. 12, right? So it's going to be the 12th root. The first fraction. How do I make the denominator a 12? What do I
Multiply
multiply?
by 4.
Okay, so I got to take numerator and denominator times 4, right? It's not too much. So it's going to be a to the, what do you think? 8, yeah. What about b? B to the
9.
9. Okay, if you write it, you're like, no, I really want my 12 under there. If you wrote that, that is incorrect. You would have to put 12 to the 12th under there. For the 12th root to actually just be 12. That's too many 12s. It's just silly. So I do not recommend you do it that way. Do it this way. Okay, put the 12 out. All right. One more, guys. You guys try this one. Oh, I lied. One more after that. Okay. Try that one. So same directions here. Write it with a radical. 6x to the 3/5, y to the 2/3. Yes. Yes.
I feel enjoyed. Ron, I didn't want I feel like it's so many
Like, are you
I love my country there's I see what you're saying. Honestly. It's like a game where you can't throw.
6 inside?
Yeah, but it's different. Like, okay, I think it's a question.
Yeah, they just have to match. Yeah. If you wanted to put it inside, you would have to do 6 to the 15. Okay. So you, I mean, you can, but I think it's easier to just write it on the outside. All right, guys. Leave your 6 on the outside. What's the root I'm looking for? 15. So that's going to be x to the 9th, y to the 10th. What? You don't think you've ever done that? Yeah. Makes sense. Look at that. Learning something new today. Okay, guys. One more of these simplifying ones just to make sure you got it. So you're simplifying the radical. Last one in your notes. Some people really like to get it all on one page. I don't know. You got it all on there? Okay, good.
Alex wrote the answer. I wrote it down. I wrote down the problem. Yeah, I wrote down the problem.
So you just gotta figure out your 32. Okay, yeah. Still on fire back there?
Nice.
Nice.
Yeah.
Alright guys, looks like you're doing well.
I don't understand how you do this every day. Yeah, I guess not. I just my first class. I hate
My sister
Alright guys.
It's not all of it.
Okay, however you simplify square root of 32, as long as you can do it, I don't care. I like to think that it's 16 times 2, and then that's 4 root 2. Okay, so I know I have a 4 on the outside. I have a 2 on the inside. X's, how many times does 2 go into 7? 3. With how many left over? 1. How many times does 2 go into 4? No leftovers. How many times does 2 go into 3? How many leftovers? Okay, there's your answer. Yes? Okay, we don't get to play a game today because of the fire drill, so we'll just look at your homework. Okay, you're going to skip several, and I'm going to change the first 2 on your homework.
12.
My brother has his entire right arm. His whole right arm, his shoulder. He has like one on his left.
A lot.
Alright guys, so skip a bunch of them. 12, 15, 17, 27, 29, 32, 37. Skip all of those. What? Yeah, so guys, and then question 1 and 2, since I'm having you do this without a calculator, change 1 and 2. Make 1 -2 to the -4th, and make 2 -2 to the -4th. But they're different, okay? They mean different things. Yes, I don't want you to do 6 to the 4th. You don't need to multiply that much, okay?
Stop at 36.
Oh,
Now you're like, I know 6 square. Yeah, let's talk about these. Those are different. Do you guys understand that? Okay, so let's just look. We'll do it with, I'll go back in a second. Hey guys, look up here for a second. I want you to understand the difference here. When it's in parentheses, -3 squared, that actually means -3 times -3, which is +9. This means -1 times 3 times 3. Okay? That's -9. They're different. All right, I'll go back to the numbers for you.